Alright, now let's move into talking a little bit about the chipset. So the chipset is a set of chips on a motherboard that work with the processor to control things such as memory, your motherboard buses, some peripherals. We have, and here's an image just to show you how easy they are to identify your chipset on your motherboard. Like I said, you can have different chipsets on there, but here's just an example of an Intel chipset. Now we have different manufacturers such as AMD, NVIDIA, VIA, and such. Let's talk a little bit about the Intel chipsets. You can have a North Bridge and a South Bridge. Kind of uses a user hub interface. And we'll use this graphic here to discuss that North Bridge, South Bridge hub interface. You can see that all input-output buses connect to the hub, and the hub connects to a system bus. So we've got the North Bridge. This is the fast end of the way the chipset works. So this control access controls things such as the video card and the RAM. We want this to be very fast, so this is why the North Bridge handles this type of information, because it is the fast end of the hub. Now, on the south end, or the South Bridge, this is the slow end of the hub. This is where you're going to see things like the PCI slots, your expansion slots being connected, even your gigabit, local area connection here, your wireless. The BIOS is supported here as well. Your USBs. These are handled on the slow end of the hub because we obviously want our RAM to be handled faster, as well as video, so we don't have that type of lag, but because there's so much processing that goes on. Now, not every chipset architecture is the same. Now, if you take a look at like the X58 chipset, this is referred to Intel as the Nephilim chipset. You'll see this with the i7. This contains a memory controller with the processor housing. The memory connects directly to the processor here, whereas we saw with the other chipsets, like in this here, our memory is tied to our North Bridge hub rather than the processor directly. We also have the Sandy Bridge chipsets, and these chipsets are with the memory and graphics controller in the processor. So whereas in the previous one we saw that these were both handled with the North Bridge. So just know that the Sandy Bridge architecture uses a single chipset hub called the Platform Controller Hub. And in this hub, you'll see it controls things like the PCI Express cards, the SATA, any high-def audio, your USBs, your Ethernet. So those are handled on that Platform Controller Hub rather than the South Bridge hub. Even yet another one is the Ivy Bridge chipsets. And these chipsets include or use different sockets such as the LGA 1155 socket for backwards compatibility with earlier motherboards. These Ivy Bridge chipsets use a single platform controller hub. And these Ivy Bridge chipsets, you'll see a lot being used a lot on the 3rd gen processors and above. Since like 2012, they are going to use less power. As we know with most electronic components, as new generations come, they try to use less power. Here's a look at the AMD chipsets. Now AMD purchased ATI Technologies, and they have what's called a GPU, or a graphics processor unit. And some of these that you just want to kind of just get a good feel for the AMD side. As you can see with the AMD A series, it has another name called Trinity. These were designed to compete with the Ivy Bridge chipsets, and yeah, that's misspelled. Sorry about that. We have the Crossfire chipsets that support ATI Crossfire. Your higher end ones, such as the AMD 780V. And then you have low end for really cheap or inexpensive systems such as the 740G and the 690 chipsets. So just get a good feel for those. And then we also talk about some of the uh, graphic processors and chipsets. NVIDIA, SYS, and VIA chipsets. If you are using these, you might be playing a gaming computer using 2 video cards. So, as I said earlier, the AMD side is more for those home-end users wanting to build something for themselves, and they're going to build what they need. Now let's move on to talk about buses and expansion slots. Now, if you're ever looking at a motherboard, you'll see all these really fine lines on both the top and bottom of the board surface. Sometimes these lines are called traces or circuits that are passed to enable data, instruction, and power to move from one component to the other on the board. Now, collectively, all these lines are called the bus, and we generally refer to those lines as the bus lines. Now, how's that signal being carried across there? How's the data? The data and instructions exist only in binary form. 1 or 0, on or off. Now, the width of a data bus is called the data path size. Sometimes you might hear it called the data bus path size. Some buses have data paths that are 8 or more lines long. It just depends on what's needed. So if an 8-bit bus is needed to transmit the data, it's going to have 8 wires, or 8 of those little lines that you see on your motherboard. Now, using this figure here, you can see that this is an 8-bit bus between the CPU and some memory, and it's transmitting the letter capital A. Now, the binary form of this is 0100 0001. Now, all bits of a byte are placed on their lines of the bus at the same time. Now, one of the most interesting lines or circuits, if you want to call it that, on a bus is the system clock. This is also called the system timer, and this is dedicated to timing the activities on the motherboard, much like a metronome helps a musician with their timing. Now, the chipset sends out a continuous pulsating electrical signal on one line of the system bus. This one system clock line, dedicated to carrying out the pulse, is read by other components on the motherboard and ensures that all the activities are synchronized. So just remember that the system clock times the activities that are being performed on the motherboard. Now let's talk about the speed of memory. This is in the front side bus, the processor and other components are measured in hertz. Now, 1 cycle per second, this is a hertz, and you're going to represent this with a capital H and a lowercase c. Now, we also have other measurements, just like we do with bits and bytes and gigabytes. We also have other measurements for the speed, and speed is measured in megahertz, capital M, capital H, lowercase c, which is 1 million cycles per second. And 1 billion cycles per second is then represented by gigahertz, and you're going to make sure you have that as a capital G, capital H with a lowercase c. Now, generally when we're talking about the CPU, we're talking about the speed of the CPU and of memory, but a better way of saying it is the frequency, because the term speed is going to imply like a continuous flow, whereas we know that frequency implies a digital or binary flow, an on and off type flow. So when you see CPU talked about, they usually talk about speed, but if you can think of it in terms of frequency, it's a lot easier to grasp that way. Your motherboard can have more than just one bus, and you can see that there are different buses, different bus types, and the data path and address lines they use. So just look those up, get a good familiarization with them, kind of know that you can have local buses as well. As an example of this, like the video buses that connect to the north bridge or directly to the processor are called local video buses because they are localized to that area.